This lesson covers the partial fraction decomposition of rational expressions with denominators containing non-repeated, irreducible quadratic factors. A quadratic factor is a factor of the form ax squared plus bx plus c. Note, if a denominator contains a quadratic factor, it is possible for the numerator to contain a linear factor. In this example, the quadratic factors in the denominator are x squared plus 1 and x squared plus 2x plus 4. I will initiate partial fraction decomposition with the linear factor of ax plus b over x squared plus 1 and cx plus d over x squared plus 2x plus 4. If we completed the partial fraction decomposition here, we would see that ax plus b is equal to 3x plus 1 and cx plus d is equal to 2, or that a equals 3, b equals 1, c equals 0, and d equals 2. The example we will work through here, 3x squared minus 2x plus 4 over x cubed minus 8, we will decompose into partial fractions, starting with factoring the denominator into x minus 2 times x squared plus 2x plus 4. So here we have the linear factor of x minus 2 and the irreducible quadratic factor of x squared plus 2x plus 4. That means we cannot factor x squared plus 2x plus 4 into linear factors. Let's set up decomposition, substituting variables a, b, c, etc. for missing numbers. So 3x squared minus 2x plus 4 over x minus 2 times x squared plus 2x plus 4 is equal to a over x minus 2 plus bx plus c over x squared plus 2x plus 4. We will multiply both sides of this equation by the least common denominator of x minus 2 times x squared plus 2x plus 4, resulting in 3x squared minus 2x plus 4 equals a times x squared plus 2x plus 4 plus bx plus c times x minus 2. Let's solve for the missing numbers for a, b, and c. Starting with, we'll let x be equal to 2, and the result is 3 times 2 squared minus 2 times 2 plus 4 equals a times 2 squared plus 2 times 2 plus 4 plus b times 2 plus c times 0. We then have 12 equals a times 12 after simplifying, and the result is a equals 1 is our first solution here. We then will go on to solve for b and c. Note that there are no values of x which will zero out factors here, so we will use a different technique to solve for b and c. Starting by, I will actually plug in a here, plug in the value of 1 for a. Then I will expand the right-hand side of this equation so that I have 3x squared minus 2x plus 4 equals x squared plus 2x plus 4 plus bx squared minus 2bx plus cx minus 2c. I will then collect the x squared terms together. So on the right hand side of the equation, x squared plus bx squared, and then collect the x squared, or the x terms together. So I have plus 2x minus 2bx plus cx, and at the end the constants of 4 minus 2c. So from the x squared terms, the terms containing x squared, I want to factor out x squared. That leaves me with 1 plus b times x squared. I will factor out x from the x terms, so I have 2 minus 2b plus c times x, and then I'll put parentheses around the constant terms of 4 minus 2c. So the next thing I do is I look at the left-hand side and the right-hand side of the equation. Note that the coefficient on x squared on the left-hand side is 3. The coefficient of x squared on the right-hand side is 1 plus b. For the two sides of this equation to be equal, we will have to have 3 being equal to 1 plus b. That tells me that b equals 2. So we've solved for b. Next, I look at the x term on the left side. It has a coefficient of negative 2. The x term on the right side has a coefficient of 2 minus 2b plus c. So it has to be true that negative 2 equals 2 minus 2b plus c. We can plug in our b value of 2 and solve for c. c equals 0. Note that we could also check with our constant terms here. We have 4 on the left side, 4 minus 2c on the right side. We can see that if we plugged in 0 for c here, we would have a true statement. And so we can see that that verifies c equals 0 is correct. Next, we use our solutions to complete the partial fraction decomposition. So I have a equals 1, b equals 2, c equals 0. And now 3x squared minus 2x plus 4 over x cubed minus 8 will be equal to 1 over x minus 2 plus 2x plus 0, or just 2x, over x squared plus 2x plus 4. So our partial fraction decomposition is complete. Try on your own. Find the partial fraction decomposition of 4x squared plus 5 over x plus 2 times x squared plus 3.